Good evening, everyone. I'm pleased to present you the FoodTraNet project number 11, titled New Chemical and Biosensors for Food Quality and Safety. A quick introduction about the project and me. My name is Eduardo Dona, and I'm ESR 11. I am enrolled at the Joseph Stefan International Postgraduate School, based in Ljubljana, but my PhD research will take place at IOS, Institute of Environmental Protection and Sensors, in Maribor. My supervisor is Prof. Dr. Alexandra Lobnik, CEO of IOS and professor at the University of Maribor. My planned secondments will be at BOKU, University of Natural Resources and Life Sciences in Vienna, under the supervision of Prof. Dr. George Kubitz, at Joseph Stefan Institute in Ljubljana, under the supervision of Prof. Dr. Esther Heath, and at ENEA, National Institute of Agriculture and Food Research and Technology in Madrid, under the supervision of Prof. Dr. Dolores Hernando and Prof. Dr. Rosario Gonzalez. Now a quick look at my CV. I'm 29 years old and I'm an Italian chemist. I got my master's degree at the University of Padova in 2018. In 2016, I participated in the Erasmus program in Belgium at the KU Leuven University. After my studies, I joined Stevanato Group, a worldwide company leader in the pharmaceutical primary packaging sector. Firstly, as a part of the graduate program for young talents, I worked in operation as a member of the continuous improvement team, and then, as a part of the graduate program rotation, in regulatory affairs. My motivation for a PhD came after 2 years of working, when I asked myself where I would like to be in 10 years. After a while, I understood that my dream is to work on advanced and challenging projects in chemistry. To do so, it was immediately clear that I would need to build a very strong background in a specific chemistry field, and a PhD is the best way to pursue it. The FoodTraNet project caught my attention since I was looking for a PhD that had the ambition to help the transition to a sustainable world. Another aspect is that I'm passionate about healthy nutrition, but also wanted a project where chemistry was used for a concrete goal. This is what I'm going to do in my project, since the goal is to warn and prevent people being exposed to harmful substances. Finally, yet importantly, the possibility to help people like me with allergies and intolerances, for a chemist who like to see chemistry at the service of our community, is a source of further motivation and enthusiasm. Since after graduation I worked for a private company, my research experience is based mainly on my master thesis. The title was Synthesis and Properties of an Electrolyte based on ionic liquids for magnesium secondary batteries. We developed a new electrolyte based on a reaction between an ionic liquid and boron trichloride, using a Schlenk line for the synthesis, since inert atmosphere was essential to avoid unwanted reactions. In the left picture, you can see the equipment used for the synthesis. We evaporated the boron trichloride from its solvent, and we made it condense directly on the ionic liquid. On the right picture, you can see the equipment used for the synthesis of a magnesium salt that acts as an ion conductor. We poured chlorobutane on the magnesium powder, keeping everything connected to the Schlenk line. Then we dissolved our salt in the new ionic liquid, and we characterized the samples with different techniques, like HRTGA, DSC, FTIR, Raman, and BES spectroscopy. Lastly, we did a test of the electrolyte in a real battery, using cyclic voltammetry. Finally, I would like to present you the topic of my PhD. The goal is to produce new nanosensors for determination of organophosphates, freshness, and biosensors for food quality. The first step will be to determine the analyte for example an organophosphate pesticide, which can have intrinsic or non-intrinsic optical properties. Then, we will proceed with the research of the proper technique to detect the analyte, like UV visible or fluorescence spectroscopy. In the upper image, you can see the detection mechanism of a turn-on fluorescence. Often, the analyte doesn't have any optical properties, so it is necessary to bind it to a receptor, causing it to become visible through optical spectroscopy. Based on these results, we will use the salt gel technique and nanomaterials to improve the performance of our sensors. In the bottom image, you can see the formation of a coating on a substrate by means of salt gel technique, where our receptor can be embedded to better detect our analyte. To produce the coating, different techniques like spin coating, dip coating, or printing are available, as you can see on the image. Finally, it will be essential to characterize the sensor properties, like limit of detection, response time, the linear operation range, and possible interfering. If this parameter will be acceptable, we will use printing technique to directly apply the sensor into an active, intelligent packaging concept developed by Attira John, the ESR 13. Lastly, the determination of organophosphate with nanosensor will be tested in collaboration with Arshit Sahai, the ESR 7. Thank you for your kind attention.